Good afternoon, everyone. My name is Dazonte Mathurin-Phaire. I'm a rice student and biology major on the UVI St. Croix campus. And the title of my presentation is Kale Leaf Growth and Water Content. My mentor is Dr. Thomas Zimmerman. You may not know much about kale yourself and ask, why did you choose kale as the topic of your study? Well, kale is a superfood, high in vitamins and minerals, and it is known to be relatively fast-growing. You can go from seed to a full harvestable leaf in 60 days or under. That's pretty quick. Now, if you're a farmer, you'll want to know which varieties of kale are the best to grow in your area for that 2 months, because kale normally grows in climates cooler than the Virgin Islands. Previously, 8 kale varieties were evaluated in Kentucky for production. We decided we would do something similar here to find good kale types for the VI by determining the rate of the variety's leaf growth, and when specifically they were ready to harvest. We also set out to determine the percent water content of the kale varieties, one of the reasons being that if they can store well, they can be used as a source of nutrients during the hurricane season. Our null hypotheses, of course, were that all kale varieties grow at the same rate, and that each variety has the same water content. When determining leaf growth, we began with seeds obtained from a commercial vegetable catalog, something any farmer might have access to. We then settled them in the UVI AES greenhouse. The seedlings were transplanted into the field in a completely randomized block design with 15 plants per variety, per block. So that's over 130 plants that I have to measure each time, with half meter between plants and 1.8 meters between rows themselves. We used drip irrigation to water the field and applied organic fertilizers as necessary. 3 plants were selected of 15 plants per variety and block that had a 2 centimeter long leaf. Why 2 centimeters? Because any smaller was hard to get to and extremely fragile, but you want to begin with a leaf that's as small as possible so that you can have accurate growth data. The leaves were measured thrice a week and all the data was entered into an Excel spreadsheet. We later determined averages, plotted them in graphs, and ran an ANOVA on the final lengths. When determining leaf water content, 10 kale leaves were harvested from 15 kale varieties and organized into 2 sets. One set of 5 leaves weighed individually, and one set of 5 leaves weighed together. The leaves were then weighed with and without the midrib, and then dried at 125 degrees Fahrenheit for 48 hours. Once the drying was done, we recorded the dry weight of the leaf groups and determined the average of the leaf weight. All of this data was then entered into Excel to make graphs. You'll see these graphs in a second. And we used a t-test to compare each variety with midrib to without midrib. For our results on leaf growth, we found that the change in daily growth is logarithmic for the first week, as you can see by the graph. After that, it begins to level out. But first, let me explain the x and y axes. The x-axis represents the number of days after the saplings were transplanted into the ground until the 31st day. We began at the 8th day for our recording because they needed about a week to orientate themselves to the new environment. The y-axis here represents length in centimeters from 0 to 7 centimeters. The x-axis for the second graph is also the same as the first in the number of days till the 31st. And the y-axis is also length in centimeters, but from 2 to 22 centimeters. Back to the first graph. So as you can see from here, the best time to harvest your kale is when the growth significantly slows, which is around the 21st, 22nd day. Alongside the growth rate, we also found that kale leaf development is a linear curve with three distinct groups. The first group I will mention is the dinosaur group, which has broad, deep green leaves, which are significantly larger than the curly varieties of green and purple. Then in the middle, we have the green curly variety, which is smaller and a lot frillier and lighter than the dinosaur. Then we have the purple curly variety, which is very similar to the green curly, but has the smallest leaves. Now, a bit of a troublesome group is the red Russian group, because they have large leaves like the dinosaur kale, but they're lighter or similar color to the green curly, and they get eaten by a whole lot of bugs, so they're not an ideal specimen. In our results for the kale's water content, we found that the kale leaf midribs significantly increased the fresh weight of the leaves. This is probably because they are quite dense and fibrous, which adds more concentrated weight. So graph 1 here, let me explain the axes first. The x-axis has the abbreviations of the different kale varieties. So RR is Red Russian, BJ is Blackjack, BM Black Magic, so on and so forth. The y-axis represents the weight in grams from 0 to 20 grams. After they were dried, the kale leaf dry weight mirrored the fresh weight trend. So it's essentially this, but the maximum dropped from 20 grams to 2 grams, which means that there's a lot of water weight in them. There was also no significant difference between the percentage water content with or without midrib, which takes us to graph 2. Over here, the same x-axis, which is dinosaur type kale, green curly type kale, purple curly type kale, and the red Russian. As you can see, when grouped by type, the percentage water content trended higher when the midrib was removed for dinosaur, for green curly, the exception being purple. Unfortunately, the red Russian's fragility only allowed us to get enough accurate data without the midrib, so we weren't able to compare with the midrib. However, we did find that all of our kale varieties have water percentages in the 80s, between 80 and 90%, averaging out at about 87% water. For our conclusions, we rejected the hypothesis that all kale varieties grow at the same rate, because clearly they don't. And we did not reject the hypothesis that our kale varieties have the same water content, because they roughly do, between 80% and 90%. We did discover 4 distinct kale types based on leaf characteristics and growth patterns: dinosaur, green curly, red curly or purple curly, and the red Russian. We now know that a 2 centimeter kale leaf is harvest-sized in 2 weeks, and dinosaur kale is the best type of kale to cultivate for the Virgin Islands. And lastly, a significant portion of kale's fresh weight comes from its water content, making it excellent for drying and storage, and useful as a source of vitamins and minerals, especially during hurricane season. There we go. This is where I acknowledge those who funded me, my work, the garden and Kale itself, who funded my mentor, and the many wonderful people who worked with me. The people who dealt with the bugs, because there were a lot of pests there that we had to kill, people who did fertilizer, watering, many wonderful people. So I'd like to thank all of them here, and thank all of you for watching. Have a good day.